Hello guys and gals, me Mutahar, and welcome to another Virus Investigations. Today though, we're not going to be investigating anything, but what we're talking about pertains to the overall series. Today is without a doubt the nerdiest day that we are going to go for. This is one video that I've had to really sit down and perfect for a little bit of a while, and that's why it took so long ever since the PUBG virus video. I had to really sit down and think, how am I going to condense this so it can be the most accessible learning guide to building your own gaming VM. Now, we're going to take a look at this as a step-by-step sort of build-off for a gaming virtual machine, but really, the reality of this is, unless you're in for a really geeky, a really nerdy fucking adventure, then this is your video. But trust me, this is going to be the one video that's going to totally confuse you. Next week, I'll go back to the, somewhat normie shit. This week, if you're willing to put up with it, you're going to see the 3000% nerdy Muta. And if you like that, then you'll like it. But sit down and let's get to building a virtual machine. So the first reason that you would want to really build this is kind of a little pet project, but there are actual uses for this in the first place. For those of you who don't know, the Xbox One, which is one of the gaming platforms nowadays, it has the, it basically uses this somewhat exact same methodology for its purposes. See, when you're playing video games on your Xbox One, they're not running, I guess, natively. They're actually running in a virtual machine that the system has created. See, the Xbox One works in a way where you have a gaming virtual machine, you could have an application virtual machine, so they all have their resources allocated to what Microsoft has set, but they never interfere with one another. They can intermingle at times, but they're pretty much their own separate entities. It's why things like Snap worked pretty effectively when it was still a feature on the Xbox One. I don't know really why it had to be removed, but hey, it did. Ladies and gentlemen, though, in this case, we're going to do pretty much what is the exact same case. Let me never tap the microphone again. But let's go into building this virtual machine. I'll give you some examples of it later, but let's get started. So step number one is getting Linux. You want to use Linux as the hypervisor. We're building a Type 1 system, so unlike VMware or VirtualBox, we're going to be using directly the Type 1 hypervisors that are available in Linux distros out there. So for this, you're going to be able to get Debian, all right? And the reason I picked Debian is because I'm really proficient with it, at least. That's what I use as a daily driver anyways. There's a bunch of Linux distros that are out there. You've probably heard of something like Ubuntu. You probably heard of Fedora or something, okay, which is definitely an applicable case for this. But I'm going to go with Debian because it just works for what we need. We need something called OVMF, and as far as I know, Debian has the updated variants of it. So really, you could use Debian, you could use Fedora, you could use Arch Linux, you could use whichever variant you would want as long as OVMF is up to date on that specific repository and variant of Linux. But let's go with Debian. So first thing you're going to do is you're going to get Debian and you're going to create an install media out of it. So make sure you get a USB that's at least like 8 gigs, all right? It has to be like 8 gigs. I think 4 gigs will work, but get an 8 gig USB. I have a 16 gig myself. Make sure you bring a USB drive.
At this point, you want to go to debian.org and find the ISO file. It's pretty easy to download, but make sure you get the AMD64 variant of it, since that's what you're going to be using on your computer anyways.
Once you get the ISO file, you're going to get something called Rufus. Rufus is a tool that'll basically let you create a bootable USB drive from an ISO file. Get that tool, follow its guides, and you should have a bootable USB drive. I'm not going to get into the super specifics of building the installation media. It's pretty straightforward, because the big bulk of this comes down with really setting up some terminal stuff later on. So once you have a bootable USB drive for Linux, it's time to get to installing it. So before we do this, before we really go balls deep, we need to make sure that our computer is capable of doing a gaming virtual machine. And before we do this, we're going to have to make a checklist. Number one, you need to make sure you have 2 graphic cards. Now, these graphic cards have to be totally separate. So for those of you who are running like SLI graphic cards, it's not going to really work for you, okay? It's just not going to be able to separate when we get to the IOMMU stuff later, as far as I recall. But you want to have 2 different graphic cards, and chances are you probably do. See, every CPU that you really have should come with its own dedicated onboard graphics. Because we're going to pass over our graphic card to our gaming virtual machine to get actual GPU performance, we need to make sure our integrated graphics is selected on. You need to make sure your processor supports Intel virtualization or AMD's virtualization variant, so it would either be VT-D for Intel or amd-v for AMD. If you don't support these, you won't be able to progress further into it, and you should stop right there. Your graphic card needs to be UEFI capable, and chances are if you have anything over like a GTX 600 or a modern graphic card, you have a UEFI capable graphic card. Nothing to really worry about over there. You should probably have 16 gigabytes of RAM. I use 32 gigs on this machine, but you want to have 16 gigs yourself. So for me, I have an Intel 8700K. I have 32 gigs of RAM at this point, but I'm only using about 16 gigs on this system right now, so I'm a little limited on that front. I have a GTX 1080, so I'm kind of doing this on hard mode, because there's going to be some little iffy segments when we get later on into the situation that you just can't really dodge. So anyways, you're going to go to your BIOS settings first of all, so you're going to power off your computer, and you want to make sure you get 2 keys down. See, in order to access our BIOS and boot menu, we need to learn how to spam keys. So you remember playing Call of Duty Advanced Warfare and pressing F to pay respects? Well, ladies and gentlemen, you're going to have to remember what key that you're using on your computer upon immediately hitting the power button to get into your BIOS settings and your boot menu. So for me, I have to spam either the delete key for my setup, my actual BIOS menu, and I have to spam F11 to get into the boot menu. So if you figured those out, you know, a little trial and error, usually it's function 9 through function 12, delete or escape, or F1, I don't know. Once you figure those out, write them down, remember them by heart because you're going to be using them a fair bit. So spam your delete key and get into your BIOS settings. Now your BIOS settings needs to be UEFI capable. Basically the easiest way to check this, if your BIOS has a mouse attached to it, you're blessed. You're more privileged than you thought you were. So go into your BIOS settings and you want to look for a couple options. So these should usually be in your CPU settings or chipset settings, and every BIOS is different. You want to make sure that you can set your primary display adapter as onboard. Usually you should have onboard, PCI, and PCI Express. So set it as onboard, and then you should also have another option which is called IGP multi-monitor. Enable that because it's going to make sure your onboard graphics remains on no matter what. Then you want to make sure your Intel VT-D is enabled. All of that stuff is ready to go. And if you have things like Secure Boot and Windows 8.1 crap that's specific to that BIOS, you probably want to turn those things off. That being said, once you've made all those necessary changes to your BIOS, exit it, make sure you plug in your USB, save your settings, and then spam your boot menu upon it rebooting again, and select your USB drive. Then you should be able to get to the Debian installer. So hit graphical installer, that should be the first option on the boot up for your Debian Linux installation. And once you're done, it's going to load up a step-by-step installation guide. So follow this as you regularly would. There are a couple special exceptions we'll get to, such as partitioning your partitioning your drives rather. If you have a totally separate drive you can install Linux to, that would be great if you have another SSD drive. Otherwise, you're going to have to get used to partitioning. For me, I had a separate hard drive that I just connected via USB, standard SSD that I had. I plugged this in and I selected the entire drive, partitioned the whole thing, let Linux do what it needs to, and install in its own course. Then the next big step is to go into your root password and set it as something that is, you're basically going to be setting up 2 passwords, your root password and your account password. Make sure these are the same thing, it's just going to make life easier for you. The reason why it's asking you for your root password is so when you get into the actual installation, you can super user into your account. It's a Linux terminology when you want to get all access and rights privileges guaranteed to you. But we'll get to that as we install it. Follow through the regular installer, it should be pretty straightforward, and you should have a working Debian install.
At one point, you're also going to reach a step where you pick a desktop environment. It isn't entirely important which one you pick, but for safety's sake, we're going to pick GNOME. And there's always KDE or XFCE, which some may be a little better performance-wise, but because I sort of use GNOME primarily, I'm going to use GNOME in this situation.
So once you've launched into Debian for the first time, browse the desktop a little bit, get a feel for it, and then let's get right to work. The first thing you want to do is definitely open up a terminal. So this would be just hitting the Windows key on your computer, typing in terminal, or just finding out where the program is. This is the backbone of pretty much how users want to use Linux. It's the power user variant, it's how you should be kind of using a lot of Linux programs in of itself. The terminal is a great tool. It is an amazing tool whether you're on Linux and sometimes even OS X or OS X or Mac OS, I think it's what they call it. I don't know. But go into the terminal and you want to type in SU. When Debian, this is super user, it's going to ask you for your root password. Type in the password you set as root at the installation, and you should be in a root at Debian account. This is basically the root account of the actual OS. You can do a lot of things that you couldn't do on your regular account. At this point, we're going to change stuff into the bootloader, which is GRUB. It's how you boot into Debian, of course. So type in nano /etc /default/grub. That's going to load up the grub bootloader files. At this point, you should be able to look at the line grub_cmd line_linux_default. In that lineup, you're going to add the options intel_IOMMU equals on. And if you have an AMD drive, I believe it's AMD_IOMMU equals on. Regardless, you should be either one of those variants. So you're going to enable them, and at that point, you're going to save it. So you're just going to do Control X, and you're going to hit Y for save, and you're going to hit Enter immediately just to save in the exact same location. Once that is done, you're going to type update-grub. As far as I recall, that's what you're going to be really introducing into the system. Once you've done update-grub, it should rebuild a bootloader right there and then. It doesn't take too terribly long. Now that you've done that, you can restart the system. So what that did is, if you are booting up Linux, you're going to look at the grub boot up screen. If you hit E anytime you're just booting up, usually it'll just do it automatically, but if you hit E, you're going to notice that in the Linux line, it basically added that intel_IOMMU. The reason we changed the grub settings is to make it so that we don't ever have to change it at boot time all the time. And there's going to be a couple things that we need to change. It's going to get annoying if you have to write them in over and over and over again, right? Anyways, once that is done, you're going to boot into Linux once more, and congratulations, you've enabled IOMMU. But we're not at the fucking sweet spot yet, ladies and gentlemen. We've got one spooky part left to do. So open up terminal again and type in lspci-mn. And at this point, it should list all of those PCI devices that you have connected to your system right here. So for me, I want to make sure that my GPU is spotted. And the important things that you're going to be noticing for is the 6 digits, usually 5 or 6 digits before where it's listing your NVIDIA or your GPU in itself. So it's usually 01:00.0 for me. And you're going to look at the hardware IDs at the end. So basically it'll be these 4 numbers, 8 digits, but it'll be separated in half by a colon, and they'll be bracketed in. So you want to make sure you note down the hardware IDs and those 2 numbers at the beginning. And you want to make sure you get both the hardware ID for your graphic card. So for me, I had my NVIDIA GTX 1080. And you want to make sure you have your audio device for that GTX 1080 as well. If you don't bring both of them, then it's you want to copy the whole thing over anyways, right? So just do that. So note them down somewhere, make a sticky note, I don't know, write it on your walls, do whatever, anything you can to remember it. So once you have done that, you're going to essentially go back and type in find into the terminal, find space /sys/kernel/IOMMU_group/-type space L. And once you've done that, this is where you're going to have to knock on wood, pray to Jesus, do something, because if your if your graphic card isn't in its own IOMMU space, you're fucked. You'll need something is wrong with your CPU's access control systems, the ACS, and it's just not able to properly isolate. It's not the end of the world. As far as I know, you can repatch Linux's kernel with an ACS patch that's floating around on the internet, but that is not something we're going to get into. It's already going to get complicated as it is, ladies and gentlemen. So luckily for me, when I did this, you should notice that your IOMMU, when it comes down to devices, and this is where those numbers, the 01:00, all that stuff was really useful, because then you can compare those numbers and hopefully see that these are in their own separate folders. So for me, they were all in folder number 1. Thankfully, usually it should be the same thing for you anyways, if you've plugged in your GPU to the PCIs that you usually would plug them at anyways. So once your IOMMUs are separate, make sure your GPU is the only one in its IOMMU group. Nothing else is in number 1 but that GPU. For me, there was 3 things: the NVIDIA GPU, the NVIDIA GPU's audio systems, and the NVIDIA's PCI link. So as long as those things were in there, I was fine. I was not going to worry about it. So if that is how your system is displayed, you're done. You're pretty much in the easy mode now. So at this point, you're going to go back to your terminal, and you're going to type in, you're going to install OVMF and Virt Manager. So super user into your account, obviously SU, enter your root password, and type in apt space install space OVMF. And then after that, for Virt Manager, you're going to do apt install virt-manager. and you're gonna say yes to installing it. It's gonna look kind of like some Hackerman nonsense, so just enjoy it if you want. It's kind of cool, I guess. But this is you installing all the necessary tools that you're going to be using to virtualize your virtual machine. So go back to your virtual machine, super user it, and type in nano/etc/default/grub. So you're going to open up your grub bootloader again, and this is where we're going to isolate using VFIO our graphic card so that our Debian itself can't use the graphic card. It's going to hold it so that our virtual machine can call onto it. If the graphic card is in use during Debian, it won't be passed on to the virtual machine, and so this whole thing will be pointless. So now it's time to quickly isolate it. So find the line grub_cmd_line_linux_default, and after you type in your Intel IOMMU stuff, just after, type in VFIO-PCI.IDS equals, and then whatever your hardware ID is, both of them, separate them each by a comma, and as long as you've done that, you've basically told Linux that you are isolating those graphic cards at boot time. So save that grub file and type in, obviously, grub update-grub, sorry. This is going to update your bootloader. You'll never have to worry about it again. Takes a couple seconds, right? Now, at this point, you're going to go and type in nano/etc/modules, and you're going to load up the VFI modules at boot time. So luckily, they have some guides online, basically from, I looked at, what was it, overt, and they basically told me to enable the VFIO modules in this specific order, or at least just enable these, so that you could use the VFI tools to isolate your GPU. So you want to type in, at the very end of this, VFIO, VFIO_PCI, VFIO_IOMMU_type1, and VFIO_VIR-QFO. So enable these, and just save it, and you should be good, ladies and gentlemen, when it comes to the modular side of it. So, just to check if we have sort of done everything right, you're going to save this and reboot your Linux install. So reboot Debian, third time, and once you're inside, load up the terminal once more. And at this point, just type in lspci-k. So this will list off your GPU drivers, but what we need to really notice over here is what driver is using it, what kernel driver. So if you've done everything right, both your GTX 1080, again, we're using this as an example, your cards might be different, your GTX 1080 and whatever we've set, which would also be the audio controller, is going to be used by VFIO-PCI. Once that's done, you're good. You're golden, ladies and gentlemen. That means VFIO is working, your GPU is isolated, you will not be able to use it for Debian. So once that's done, it's time we start setting up the actual virtual machine. So I'm going to leave a link in the description below. This goes to fedoraproject.org. You're going to download the virtio-win ISO. This is going to be the virtio drivers you're going to be using when you're installing the Windows on the virtual machine. So download this somewhere. Just get the virtio-win ISO file and save it somewhere. You also want to go to Windows 10 and download the recent Windows 10 ISO file. You don't need to buy Windows 10. It's just going to put a watermark on your screen anyways. If you have a, I guess, subscription for it or a CD key, then go for it and get it. But just download Windows 10, the ISO, and put it somewhere on your computer that you remember. So once that's done, this is where we're going to open up Virt Manager. So find the Virt Manager program, Virtual Machine Manager, whatever it's called, on your Debian install, and load it up. You're going to need your root password. So whatever password you were using for SU, super user, just put that in, and it should load up the Virtual Machine Manager. So here we're going to go and create a new virtual machine. And we're going to select the Windows 10 ISO file, and then we're going to go into where it asks for memory and CPU settings. We're going to give it, I gave it 12.5 gigabytes roughly, and CPU, I'm going to give all of it, but just put 4 down for now, or 2, whatever you want to call it. We'll change this later. So as you're progressing through, you want to make a 40 gig drive. In the video I made 25 gigs, just make 40 gigs. I kind of fucked up halfway in with the Windows install, but go with 40 gigs. And next, calling the virtual machine, call it win. Okay, this is going to make it a lot easier when we get to it later on. So just call it win, and once that's done, click Customize Configuration before install. So here we're going to change a couple things. In CPU, or sorry, Overview first, we're going to go to Firmware, and we're going to change it from BIOS to UEFI x86-64. And in where it says chipset, we're going to change it to Q35. It might give you a little warning, just we're going to need Q35, just let it do what it needs to, just ignore it. Hit apply and go to CPU. Now this is kind of important. What you want to do over here is you want to do copy host CPU configuration. I have an i7-8700K, so for me I have an Intel Coffee Lake processor. Really what you want to do is you want to know what your processor has down to the nitty-gritty. So note your processor name down and go to either Intel's ARC, which is their details for all of their processors, or AMD's equivalent, and get the raw information on it. Because what's important over here is topology. And topology, for those of you who may not know here, is CPU topology is basically how your CPU is, how your CPU functions, what its core structure is like, I guess you could say. So for me, an i7-8700K is a 6-core processor, but it has 12 threads. Threads are basically, threads are, to a computer, it's like a core, but to the actual nitty-gritty details, a thread could be virtual or it could be real. See, what an 8700K has, it has 6 actual cores, but it might have 12 threads. Now, the way that a system is designed is that each core has 2 threads. So 2 cores, I guess you could say. It has 1 real core, but it has 1 virtual core for every real core. So on what I'm trying to say basically here, is without getting super confusing here, is my i7-8700K will be a 12-core machine, but it'll have 6 real cores, and for every core, there'll always be a virtual core on that. So when you're setting up the system, sockets is always going to be 1, because we only have 1 CPU. That's the CPU. It's a 1 socket. The cores are going to be 6, because there's 6 real cores, but the threads are going to be 2, because for every core, there are always 2 threads. And we're just going to match it one by one. And if everything is done right, when we go into the virtual machine, it should recognize the 8700K as an 8700K. If you go into the configuration and select Skylake, it's going to cause some compatibility issues. We're not using a Skylake processor. We're not using KB Lake. I'm using a Coffee Lake. If you're using a Skylake processor, then maybe it might be the option, but at that point, just click Copy Host Configuration. So, once that is done, we're going to go to memory. Don't need to change much. Just set both numbers the same. Keep the allocation maximum, whatever you want to call it. Boot options, you're going to go in and we're going to save that actually for later. You're going to go all the way to the disk that you made, right? So that was the 40 gig that was created. You're going to make sure you change the disk bus from IDE to VirtIO because it's going to be faster than the IDE default. In performance options, you're going to go to cache mode and you're going to change this to write back. And your storage format must be QCOW2. All right, this makes it easier to manage in the VirtIO settings. So at this point, we're going to delete the pointless shit. So tablet, display spice, console, channel spice, video QXL, and the USB redirections 1 and 2 can go. There's no reason to have them. Now at this point, we're going to go and we're going to add 2 disk drives. So delete whatever disk drives are already on, go to the add hardware, and in storage you're going to go to device type, CD-ROM device, you're going to keep it SATA, not SCSI, and you're going to go find your Windows installation ISO that you downloaded from Microsoft. Next you're going to go to add hardware again, you're going to do the same stuff, go to the storage, disk device, VirtIO, and you're going to set the VirtIO Win ISO that you downloaded from Fedora project as your second disk. Now, at your NIC, you're going to change that to VirtIO, where it says device model. And then finally, you're going to do the creme de la creme and install your, apply your new GPU that you isolated into the virtual machine. So go to add hardware and go to PCI host device and find your graphic card. So everything that you isolated, which in this case was the GTX 1080 and the GTX 1080 audio device, you're going to select both of those and call it a day. And then you're going to go to add hardware again, and you want to make sure you have a secondary keyboard and mouse plugged in, because you're going to lose access to your keyboard and mouse once the system fires on. You could get programs like Synergy later on, and that might help you out for sure, but for now, you're going to need a separate keyboard and mouse. So connect those as well. Just use controller, just go to add USB host device and add both your mouse and keyboard. And at that point, you pretty much should be fine. You go to controller USB and just change it to USB 3. And in your boot options, you're going to enable boot menu, and you're going to select the SATA CD-ROM, which has the Windows ISO attached to it, so it should be CD-ROM 1. and then you want virt.io disk 1. So you're going to put cd SATA ROM at the very top and then virt.io later. You want to boot into Windows first, right, to install it. So once you're done, hit save, and then finally hit begin installation. And if all goes well, the HDMI cable that you have plugged into your graphic card to another monitor, please make sure you have a second monitor, please God, you should be able to get Windows popped up like you would a standard separate system. Now, if Windows is loaded up into its setup, you are good. Force close the virtual machine. Just shut it down, and let's go back to doing one final step if you have an NVIDIA card. Now again, this step is only, I think, if you have an NVIDIA card, but it's just good practice to do it anyways. See, the reason why we need to do this step is NVIDIA is kind of a cunt about this situation. They love the idea of preventing you from using virtual machines. Basically, installing an NVIDIA driver is going to be tough on the virtual machine because you just won't be able to install the driver. But if you manage to hide the fact that you're using a virtual machine from NVIDIA, then you can install the drivers. AMD, as far as I know, has no issue, so this is for those people who are on an NVIDIA driver. It's pretty easy to do. I'll just walk you through it real quick. Luckily, the Reddit communities for VFIO and KVM gaming are alive and well, and luckily the users over there have all contributed piecemeal to helping out with figuring out how the situation works. So, go back to your terminal and super user into the account again. And at this point, type in virsh edit and then the name of your virtual machine, which is, in this case, is win. So type in win. And if it asks you for an editor, just do /bin/nano, which is what we've been using anyways. So once you've enabled that, you're going to see your virtual machine settings. So this might blow your mind. In this instance, the main things that you want to change is you want to apply a dummy libvirt page. Now, as far as I know, I don't think this option is necessarily needed, but we're just going to do it anyways because it's what I learned from the community and it worked. So where it says domain type equals KVM, before that line essentially finishes, you're going to add this dummy libvirt page. So you're going to do xmlns :QEMU equals, and then I'll just leave the link of the actual page that you need to leave in. This page doesn't lead anywhere, so I don't know why it's exactly super necessary, but just leave it in there. I mean, you could probably put this as like, I don't know, www.google.com. Just keep it exactly the same that I've done it. So at the very end of it, you're going to go, just before the /domain to end it, you're going to type in QEMU :command line, and then you're going to do this exact entry. So you're going to do value equals negative CPU, and you're going to do value equals host, hardware time, KVM off, vendor ID null. What this string does, this command line string that we added, is hide KVM from the actual OS that we've installed. Since Windows 10 is virtualization aware, it'll know that you're using a hypervisor. But if you enter these strings, Windows 10 isn't going to be any wiser. So once that's done, and you've entered it right, hit Control-X, and then save it, enter it, and everything should work fine. This should save it properly. And as soon as that has happened, you should be able to reboot the system, and then start up the virtual machine again. And if all is going well, just install Windows like you would normally on that system. And when you're doing it, there are a couple key differences, just remember that. Since we are using virt.io, which is a faster methodology of installing, you're going to need to actually install those virt.io drivers during install as well. So when you're installing Windows, and if it can't detect a drive, it's because virt.io hasn't had the drivers installed. So just manually add the drivers in yourself. Basically, it's as easy as going to that ISO you set, which should be the second DVD or CD on the Windows install, and you're going to go to, I think it's VFIO store, and then inside it's going to be Win10. You just enter that, do the x86, because we are installing a 64-bit version of Windows, select the driver, and you should be good to go from there. Once Windows is installed, you can go down to the entire aspect of installing your drivers, installing the virt.io network driver as well, because you do have to go to your device manager once Windows is installed. So if everything works and you're in the Windows installation, it's time for you to install your drivers. So go back to your Windows install once everything is set up. Go open up Device Manager and install the network drivers for VFIO. It should just be on the same disk anyway. It should just be like VFIO or like net it should be like a network folder or something on there. Regardless, I think you can just go into the actual system and just let Windows find it yourself. But install the network drivers, and once all of it is done, you should be able to install the NVIDIA drivers. It should all just be doing it itself through Windows Update. So once everything is done, your virtual machine works, and you can use all your multi-monitors because it's just using the GPU as it normally would, and you should be fine. If you go to your task manager, you should be able to see that your CPU is registered as an i7-8700K or whatever your CPU is. Your RAM should be how much you gave Windows in the virtual machine settings, and at this point you should be fine. So now it's time to actually do some gaming. So before you do this, once you're done all of the installations and general crap, close the virtual machine, and I would highly recommend that you should clone this. It's just a matter of going to your virtualization manager, right-clicking and cloning the virtual machine, and at that point you should just be fine. That way you would have like a save state so that you can just, if anything fails in this situation, you can always wipe a virtual machine, re-clone it, and restart it from a fresh thing in a matter of minutes. So you don't have to reinstall Windows anymore, none of that bullshit, you're fine. And at this point, you can install your games through Steam, Origin, Uplay, or whatever, and play them like you normally would. So ladies and gentlemen, we just created a virtual machine that can game. So if this video was a little heavy-handed, it's because it was. And trust me, I did the most I could to condense this. But there's just a whole lot to this kind of stuff that, frankly, I can't condense further than what I've already have. So if you were a little blown away by it, watch the video again a couple times. Let me know if I could maybe make it better, sometime later on, because it is kind of still somewhat new to me too. But regardless, you should have a virtual machine that you can game on. Again, as long as you feel comfortable about it, you should be able to pull it off. This is how I did it, and it works. Now, as far as gaming goes, I'm pretty much reaching native performance. I picked the games that were going to be the most demanding for me in this situation, which were Final Fantasy 15, and it was going to be Deus Ex Mankind Divided, Far Cry 5 I also tried. A lot of the newer games that were going to definitely use up my cores, RAM, and GPU, I tried those out, and they all worked pretty fine. Minecraft was running okay, even with it's Minecraft, it was going to run fine no matter what. But what I would not recommend you do is play multiplayer games like Rainbow Six Siege or Counter-Strike, anything that needs multiplayer. And that's solely due to the fact that with virtual machines, the programs that you're using or the games might have an anti-cheat software in there that might recognize you as a cheater. I know that Counter-Strike Global Offensive will give you a VAC ban if you use a VM, so just don't do this on a multiplayer game. Single-player games, you're fine. Multiplayer, probably don't want to fuck with it, okay? Leave it alone for a little while. I've read people who played like hundreds of hours of Siege without getting banned. I wouldn't risk it myself, but if you're playing single player, you're going to be fine. Just for shits and giggles, emulate fucking video games so you can have an emulator running within an emulator. Who knows, right? It could be crazy. But ladies and gentlemen, while we have done something crazy, the argument does come again, why don't I just install Windows to a separate hard drive? You can, but this is just kind of more nerdy and fun. Really, if you're in for something, if you're in for a pet project at a time, just go do this if you feel like it. Would I personally recommend you do it? Probably not. Just install Windows to a separate hard drive. But there are actual uses for KVM. KVM goes great into the server world as well. If you're working servers, KVM is a great tool to have. And even modern day emulators might be using KVM as time comes on. For those of you who don't know, Orbital, which is a PlayStation 4 emulator that's currently in production right now, is actually using KVM and QEMU OVMF to emulate the PlayStation 4 OS onto an actual system. Because the PS4 and Xbox One are x86 64 systems, it's not too out of the ordinary to use something like KVM to just load that up near natively on a system anyways. Is it doing anything crazy right now? Are we running a game? No, we're not. But at least we've gotten PlayStation 4's Orbis OS to load up. So yeah, a little cool stuff that KVM is doing nowadays. But I'm going to end this video right now. I'm pretty sure it went off long enough. Ladies and gentlemen, we've built a gaming virtual machine. So now you can play Fortnite in front of your friend. Actually, do not play a multiplayer game online. Don't fucking do that. But you can play any of your game and tell your friends, you know what, I did it on a virtual machine. How about that? But that being said, ladies and gentlemen, I think my voice is about to give out. I'm feeling genuinely drained from talking about building virtual machines right now. That being said, enjoy your gaming VM. Let me know how it turned out in the comment section below, or how much your computer got fucked up in the process, or if you fucked that toaster or something in step number 8. I don't know. That being said, ladies and gentlemen, if you like what you saw, please like, comment, and subscribe. Just like if you dislike it, I am out.